Students, welcome back to another video. This time we're going over practice set 6. I posted that. And so basically, this is a small video just going over basically how we solve practice set practice set 6. And this one I'm going to do slightly different. Usually when I do your solutions, I do them in Excel. But this time I'm going to show you this in pandas because it might be, I'm going to show you directly in Python code because it just might be easier to show you the results of what's going on the Python code. So the first thing I do is I create a file, right, BAP_PP6. And yes, I'll be posting this for you guys. And what I do is I want to recreate the table here, the pandas table here. So I create an A column, a B column, and this text column with this text in it. I went beforehand and I just wrote this stuff up. And so I have it here, and I'm going to run it. And now I have the data frame. That looks like my table. See, perfect. Thanks so much for driving me home. Thanks so much for cooking dinner. I really appreciate it. Excuse me, sir, etc., etc. From here, I'm going to start answering the questions. Question number 1. Create a table df2 with just the columns text and B from table df, right, from this table df. That's easy. We've done this like tons of times. Multiple ways to do it. Number 1, df2 equals df. I'll use a double bracket system, and what do we want? We want just text in the B column. All right, in that order. All right, done. Text, comma, B. I run this. I now have a df2 table, and now I simply have the text column in that order because I selected it first, and the B column. Real easy. All right, number 2. In table df2, create one column named text L. That is all the words from the text column in lowercase. Now, in this case, I never showed you this function, but I did talk about the package that has these text objects, all right? So in this case, I'm creating a new column called text L. Text L. This is going to equal all the words from the text column in lowercase. Excellent. So I'm making a new column based on text, but I'm making everything lowercase. Now, how would I do this? Well, I mean, it's very simple. Again, I'll simply call the df2 my text column. All right. And now, which package I'm going to use? I'm going to use the str package. In the str package, there's a whole bunch. Unfortunately, I'm not going to have, it's not doing the drop down. But if I did str on your machine, maybe you're seeing it. And there's a function literally called lower. str.lower. And when you run this, right, click on df2 right here, you notice I have a text L column, which is the same as text, except everything is now lowercase. Just like there's a text L, just like there's a lower function, there's an upper function. The str package, again, this within pandas and numpy, within pandas actually, I'm sorry. Incredible amount of functions within it to do text manipulation. All right, to do text manipulation, it's fantastic. Let me make it slightly bigger. This slide is better for you guys to see. All right, number 3. In table 2, create one column named text list. That is the textl column that we just created with the textl value split into words into a list. So basically what we want to do is we want to create another column that has a list in it, right? And basically in that list will be words. And those words will come from the textl column. Those words will come from the textl column. You guys remember how we did this in our lab? So in the slides, if you remember in the slides, I used a split function, right? I used a split function. I used basically an np.split function. You remember that? Okay. So we could use that again if we wanted to, but again, we have the str package there. So we don't need to do np.split directly on it. We could just do it directly on the column, call split on the column through the str package, right? And we want to create this text list. Now remember that when I used it in my slides, I put a parameter. Let me first do this and explain you the difference. So I did text list. All right, so this will be text list, and I'm going to take this column and I'm going to call split on it. Now, when I use this in the slides, this is what I'm talking about. I had put like something in it, some sort of quote or some sort of string. What'll happen is whatever you put in it, it'll split. It'll split according to that text. If I put nothing in there, then it simply splits it by what? By empty space. By default, it'll split it by empty space. So if I run this right here, right, and now let's look at the df2 table. Make this bigger. Right, and let's make this bigger a little bit, okay? Fit that in. It's kind of small, you can't see, but you can see on your own machine. So what happened is, because I didn't put anything within this parenthesis of the split, thanks so much for driving me home, each one of those words became its own value because it's split by the space. It's split by the space. Had I put the letter A split and then just the letter A, then how would it have split, guys? That's right, it would have split according to the A's. So it would have just found all the A's and split the text according to all the A's. In this case, it looks like there's just one A here, so there would have been just two values, two splits. Now, another thing you want to notice is that text is text. This period is still considered a text. So when it splits, that period is still attached to that word. Okay, that period is still attached to that word. Here you see that here. Let's see, right here, sir. This is a tricky one because there's a comma right there within the quotes and a comma right after, so you might get confused because the quote is there. It's part of that word. All those periods, question marks, whatever, they're going to be attached to the word when you just do a generic split with no other, nothing in the parameter. In my slides, I had put in like a quote or a few words and split according to those quotes. So we have these flexibility what we split in. In our lab, remember, we split according to that invisible character /r/n or /n/r, the return characters, and how we split that one massive line into several lines, which eventually became our rows in our lab. All right, number 4. In table df2, create one column named text array that is the text list value converted into a NumPy array. All right, so here we just want to make everything in text. Or somebody will call this. We'll call this text array. All right. Text array. And this is going to be text list, all the lists and text. Remember, because when you use split, it creates a list, right? So now we want to take that list again. It's a list. You know it's a list because you see those commas, brackets and commas. Now, what's weird here, we're going to convert this to an array. And when we convert it into an array, right, we're obviously going to use the apply function. Now, you can go ahead and use lambda if you want, but when you use something like NP array that converts to everything in the data item, there's a function that's going to be where everything in the text, for instance, the text set list, every content in it is going to be put as a parameter in the function, which is the case for np.array. We could just put in np.array, and that's it. The generic np.array function, and automatically apply will say, take this function and put everything in here within it. We don't have to call lambda x, but if you wanted to call lambda x, that's fine as well. I'll show you that also. So this ran df2, and text array looks just like text list. Like you wouldn't be able to tell that they're different, aside for the text. The NumPy array has no commas. Do you see that? No commas. No commas. So that's a subtle way of seeing the difference. Subtle way of seeing the difference between a list and a NumPy array. And of course, if you wanted to, you could have done it like this as well, using lambda in this place. Apply lambda x, or whatever variable x you wanted. Again, this is just whatever you want. And you could have simply done something like that. Either or will work. Either or will work. All right, number 5. In table df2, create one column named text adjust, that is a text arrays with the words I and me taken out. Oh Lord, I and me taken out. How do we deal with that, guys? All right, how do we deal with that? So let's do a quick refresher of how that would work. Right? Remember, we did something like that before. Not like, well, the functionality we used before early on, I believe in our first lab. And there's something I showed you called isIn, a function called isIn. All right, so for number 5, we want to basically create another array with I and me taken out. Let's do a small example. All right, so let's create an array A that's going to have the values. All right, let's do A, B, C, D. All right, very simple array of text, A, B, C, D. Now, if I wanted to create another variable called B out of A, right, out of A, then I would simply say, all right, cool, A, so from here, I have this array, and if you remember, there was an isIn. We actually use it in pandas, but NumPy has it as well. This function called isIn. Oh, there it is, right? IsIn. Now the way isIn works is, you basically are testing to see, hey, does this object A have any of these values in it? Let's say we do B, comma, D. All right, and I run this, and what do I get? I get a Boolean value, right? Because it's asking a question, and it gives the answer, true or false. So in this case, does A have any of these values in it? Well, of course. A, false, right? So literally, it's going through A and seeing if any of these values are in there. And I could put as many values as I want. Remember how we did this before? In our first lab, actually, in our first lab. And here it's saying false. That's that's not a B or D. This is true because this is a B or a D. Excellent. This is false because C is not in a B or a D. D, this is true because D is in B or a D, right? It has to be just one of these, as big as I make it, right? So this gives me true and falses. So what do we know about Boolean slicing, guys? We talked about this again. If I simply take this list of true and falses and place it directly into my data container with the slicing, because this is how we do Boolean slicing. Now if I do this, right, I get my values in array, and this is kind of redundant at this point, right? This is kind of redundant. But I mean, think of a scenario where you have a NumPy array of like 500 values, right? Okay, and you're filtering for all the B's and D's. But here we get the values back B and D, all right? We get the values back B and D. All right, that's easy. That's easy enough. Now, what if we want the opposite of B and D? Let's say we want all the values. Let's say we want all the values in A that are not B and D, that are not B and D. Then what do we do, right? Then what do we do? Actually, let me copy this first. So remember, this gave you the true and falses for anything in A that's a B and D, right? And if I want all the, if I want all the values in A now that are not B and D, I simply add the tilde before it. And what that does, ladies and gentlemen, that's like the exclamation point. I don't know why they use tilde, but that's like the exclamation point in Java and C++. That means not, or the opposite. So if I do tilde, now you will notice, guys, that my Boolean's results are now reversed. My Boolean results are now reversed, okay? Here, again, A. Is A not in B and D? True. Is B not in B and D? False. It is. Is C not in B and D? True. Is D not in B and D? False. It is. So over here, if I simply put in the tilde, this now gives me all the values in A that are not in B and D. Boom. And that's how I get the values. All right, see, so let me comment this out, by the way. Boom. Boom. All right. Using that logic, people, now let's tackle number 5. In number 5, I'm saying, right? In number 5, I'm saying, create a column named text adjust that is a text array column, with this NumPy arrays, but with the words I and me taken out. All right, let's do that. This is text adjust. It's going to equal. It's going to simply equal text array, except we're going to apply some little lambda tricks to it. And I used x as a previous variable there, so I'll use a different one. I'll use I. All right, just to reinforce that these are variables. They don't, they're just like our for loop variables, iterators. We can use them any way we want. And now what I'm going to do is I'm going to play the same trick here. So now what is I going to be? I is going to be the NumPy array in each one of the rows in this column. Okay? And to I, I'm going to say I, just like I did here, bracket, tilde, np.isIn, I, comma, and now the words that I don't want. I don't want. And I don't want what? I don't want, number 5, where are we? I and me. I don't want, wait, lowercase, excellent. Let's do lowercase I, because I made everything lowercase. I and me. All right, this should be lowercase, because I will be lowercase. We're going to confirm that in a moment anyway. So I'm going to take that, go ahead, apply it to everything. And again, this is why I say this is medium level pandas, because now you're in there intricating, changing the values subtly within the values within the cells. Do you see that? We're now changing. Now, before we obviously could change values of cells, but now we're changing parts of values within cells, parts of values logically within cells. And this is why it's getting more complex and dynamic. So now let's click on df2, and let's make this guy smaller, this guy bigger. And this is, by the way, why I wanted to do this in pandas, so you can see this live happening. All right. So what do we move? I and me. Where do we find? Okay, here's we have a me. We got a me right here. Excuse me, sir. That turns into excuse, sir. You dropped your wallet. Excellent. I wasn't expecting anyone right here. Turns into wasn't expecting anyone. The IMs aren't affected because, again, IM is part of the, it's not I, it's this whole word, text word. Oh, right here. I really something after dinner. Thanks for coming to dinner. Blank really. The I is gone. Boom. That simple, right? It's that simple. Next question. Number 6. So we have 9 questions altogether. Pretty light practice set. Number 6. In table DF2, I create create one column named text adjust 2. That is the text adjust column, right? Those NumPy array values, with the word Batman inserted as the first item in the array. All right. So now what I want to do is I want to take the NumPy array from text adjust that I just created, where I extracted out I and me, and now I want to put Batman as the first value in the array. Okay, the first value in the array. Now, basically what we're doing here, we're doing an insert, if you want to think about it. We're doing an insert. Okay, now there's 2 different ways you can do this. There's a low-level way you can do this, and there's a fancy way to do this. I never showed you the explicit function, but I'll show it to you now. All right, but here, if we go back to number 6, and this is going to be text adjust 2. Actually, before we jump into this, let me show you a simple example. So let's create another array. Let's do apple. I just want to show you the insert function. Apple, plum, cherry, right? And now, so we have this NumPy array, with the words apple, plum, and cherry. And I want to insert now mango to the front NumPy array. Now the cool thing about this is that I have a insert function called np.insert that will go ahead and insert this for us. So the way it works, let's overwrite. Fine, let's do b equals np.insert. You'll see this pop up. Boom. All right. The first argument I give it, the argument's right there. Is basically, you can see that on the screen, is basically the array. So which array I'm going to give it? I'm going to give it A. All right. Now, what's the object? Basically, what do I want to put in array? I want to put mango. Values, where do you want it to go? I want to go in the first spot. Boom. I go ahead. I run this. Oh, I think I mixed up my spots. Hold on. All right, now let's do it. Excellent. And B worked out fine. So it's basically the NumPy array that you want to append or insert something to, where you want to insert it, and what value you want to insert it to. If I type in B over here, you guys can see my new NumPy array. And the cool thing about insert is, again, the flexibility it gives you about where you want to add these items within the NumPy array. Right? That's the cool thing about NumPy array. It gives you this. It gives you all these different places where you can add these values. All right. Okay. So here you see mango, apple, plum, and cherry. Excellent. From here, oops. All right, we're applying the same logic. So I'm going to do this two ways. I'm going to do this using the insert, and then not using insert, a way I consider slightly more painful. But so here, text adjust 2, what I'm going to do, I'm simply going to say text adjust dot apply a lambda. Now going to be, let's do lambda b for Batman. Right, and again, it's going to be b, just like I did up here. All right, b, actually insert np.insert b will represent the that NumPy array within text adjust, each cell within text adjust. 0, the first value, and put in lowercase Batman. All right. I go ahead and run this. Click on df2, and looky, we can see clearly that Batman has now been appended to the first value of every NumPy array of text adjust. What's the painful way I was talking about before? Well, not necessarily painful, but maybe slightly less intuitive. So again, I would do apply. Let's do apply again. I'll keep it at B. Everything here, this part is going to be the same. So this time what I'll do is, remember the fact that lists, when you add lists together, they concatenate with one another. So if I just have a list called Batman, right, and I just concatenate it with what? I concatenate it with a with my B array. But remember, if I do the B array, then it has to be converted to list, right? To list. All right. But now what happens is, text adjust 2 in this case is just going to be a list. It's going to become it's going to go from a NumPy array to a list. So to convert this back into a list, then I would do np.array. Yeah, see, this is why I mean it's way slightly more painful, because it has so many more moving parts. So you could have done it like this as well. Took B, converted it back into a list, concatenated the Batman list to the front of it, and then convert that list back into a NumPy array. And this also would have worked just fine, right? Either or will work just fine. And if I go to df2, you can see that here, it's still numpy rate, no commas, and Batman's up there. Alrighty? Okay, let's do number 8. No, number 7. Move up a little bit. Number 2, table 7. All right. So number 17. Okay, number 7. In table df2, create one column named text adjust 3. That is text adjust 2 arrays with any word with the string ing removed from the arrays. Okay, this is slightly complicated. This is slightly complicated because now what we want to do is we want to get rid of, we want to go through each element in our text adjust text adj2 array within each column, within each row in the column, and then now we want to get each word in there that has an ing, find anything with the ing in there, and we want to remove it from the arrays. We want to remove it from the arrays, all right? We've done something similar like this in our lab before, right? Using what function, guys? What function was it that we used something similar like this before, where we looked for a keyword or something? Contains. We used the str contains, okay? The str contains. Now, the problem here is contains worked, when we used str contains, it worked for each value in the cell, right? Each value in the cell of the pandas table. In this case, we now have numpy arrays in each cell of the pandas table. And we want to go within each numpy array and find if there's anything with an ing in it, all right? With an ing in it. That's the complexity right there. So we do know, what's unfortunate is that we don't have a contains-like function in NumPy. So we're going to have to use the pandas contains-like function. So ideally, the way we're going to solve this is kind of a funky way. We're going to create a, on the fly, in our apply, we're going to turn each NumPy array into a one column table, filter each row for, and then filter each row for ing, and then reconvert that table, once we filter that out, convert it back into a NumPy array for this new column text adjust 3. So let's do this for one hypothetical cell, just so you understand where we're coming from. So first things first, let's take a and let's create some words in it. Eat, eating, walk, biking, sleep. All right. So clearly I have five values. 2 of them have the ing term in there. So basically what we're going to do is on the fly, this is going to happen on the apply map, right? This is what we're going to do. So I'm going to create, I'm going to do this to show you this 2 ways to understand. So what's going to happen? So basically what we're going to do is we're going to create this table, all right? So now I have this table called DFA. Type this on the side, and you guys will see you have this nice little table right here. All right, once you have this table, what you're going to do is you're going to filter all the elements in this table, DFA, all right, where DFA A dot contains ing, right? So if I do this, guys, oh, sorry, forgot my str package. This is all within the str package. I go and run this, and now the result you see, guys, is this. You literally will get this back, right? You're going to get everything that has the ing in it. So, all right, so that gives us eating and biking, if you can see here, eating and biking, right? From our table, right? From our table, that is DFA, right? That's DFA right there, okay? Now, remember, we want with the string ing removed. All right, no problem. So in this situation, we don't want necessarily the ones with the ing. We want the situation with tilde again, not containing. So when I run this, aha, take that, boom. Right, as you can see, it's giving me eat, walk, and sleep. It's giving me eat, walk, and sleep. It's giving me the ones that aren't a numpy, I mean that aren't the ing. Now from here, remember, this gives me back the results as a table, right, as a table. So how do I get this back into a numpy array? If I simply just do this, right here, dot values. And now I get what I want from the beginning. I started with an array, or in this case, I started with a list, but you know, you get the gist. I started with an array and I end with an array with the ing removed. That's the logic we want to apply. That's the logic we want to apply. The dilemma here is we can't really, so lambda x doesn't allow us to choose, I mean, we can write basically our own function if we wanted to, but it doesn't allow us to first declare the table. It doesn't allow us to declare the table and then use the string containing, right? So in that situation, pretty much, the trick I'm going to use is I'm going to basically say, you know what, let's do it on the fly. All right, and the way I'm going to do it on the fly is I'm going to use PD series. So here I did the example as a table, but I can do the same example using a series. All right, PD dot series. Okay, so I'm filling in whatever. PD dot series A up there, A. All right, PD dot series A. Now this is going to create a series, and usually what I would do is I would say S equals PD series or whatever. But this time what I'm going to do is I'm just going to roll with the function. So PD.series will be a table. If I just run this part right here, as you can see, it's a table. I'm not sorry, a table. It's a series, right? It's a series, but it's not stored, right? It's not storing it. It's not storing in a data container. It's just happening on the fly and dynamic. I'm going to use that to my advantage. So here I'm going to say PD.series A, right? PD.series A, and I'm going to apply the same logic I did before. All right, I'm going to say PD.series A, dynamically throw PD.series A in there again, right, and do the .str .contains ing, because remember, the series shares the same libraries as the data frames, right? So we have the string contains in series. And if I run this, look how I call it all dynamically. Nothing is being stored. There's no data containing being stored. All I am is getting the output right here. All I'm getting is that same output from up here, okay? And if I put the tilde in there, this is all happening dynamically in the fly. It's all happening dynamically in the fly, and I get my eat, walk, sleep. See, I get those things out of it. And again, if I simply just can put the dot values afterwards, I get the array. I get the same array up here. That's the okay, let me comment this out. I'm throwing errors all over the place, but that's the logic we want to do. It's basically the same logic we did with the tables, but this time we're doing it on the fly with the series. And this works because when we do PD.series to A, that is a series. It's just that we're not storing it anywhere. It goes away, nothing's being stored. But we can apply all the functionality to a series that's being done in the fly over here, right? It's being done on the fly We can apply all that logic even though it's not being stored. But what is going to be stored is the values part. So using this logic right here, you guys pretty much understand what's going to happen next. I'm going to take this, say I want it to be text adjust 3. All the string ings removed, all right? So this is now going to be adjust 3, right? This is adjust 2, dot, apply, lambda. In this case, let's use the variable p for panda series, or s for series. And now we're going to apply the logic, right? S is now going to be the value, the numpy array within text adjust 2. And I'm literally going to just copy, I have to scroll this over here. All of this, but instead of A, right? So instead of A, it's going to be S, S. See that? That's it. Same logic as before. I'm going to highlight this. I'm going to run it. No errors here. Let's open up my df2 table. And we have the text adjust 3 column. Look what happened. First of all, let me identify all the situations where there was, okay, excellent. Batman, thanks so much for driving. Batman, thanks so much for, it's gone. The next word is home, it's gone for home. Batman, thanks so much for cooking. Batman, thanks so much for cooking dinner. Batman, thanks so much for dinner. Cooking is gone. Where else? Learning, Sophie, Batman, my name is Sophie, and I'm learning English. Batman, my name is Sophie, and I'm English. All right, bam, dropped all this stuff off. Right, and that's basically right there, the solution to number 7. Finally, we're on number 8. Number 8, in table df2, create one column named text new. That is text adjust 3 arrays concatenated into new strings. We know how to do this, guys. We're going to use the join command, all right? So this should be easy. We're going to use that funky join command. So that new column is going to be text new. All right, text new, text adjust 3 equals text new. All right, per row. And what do we do? Again, apply map, apply lambda. Someone, I'll use J for the join. And it's literally going to be quote, quote, because we want no space in between each, we want no space in between each word. Oh, do we want a space? Yeah, it's a sentence. Okay, cool. So I'll do quote space. So we have each word, each element will have a space between it. Dot join J. All right, go ahead, I run this. Click on df2. Look at that. No vectors, no nothing. Batman, thanks so much for home. Batman, thanks so much for dinner. Really appreciate it. Batman, excuse, sir, you dropped your wallet. Batman, I'm sorry for the mess. Wasn't anyone today. Batman, my name is Sophie, and I'm English. Boom. All right? It's a silly example, I know, but still, I hope you see the power and applicability in this. And finally, the last question. In table df1, create a we go back to the original one. Create a column C. That will be the first and last words of the values in the text columns. Okay, here we go. All right, that'll be. We want df1 create. We're going to create a column C. That will be the first and last words of the values in the text column. So I don't say give me a numpy array. I don't say give me a text. So basically, I want to create, I guess, a sentence with just the first and last word of the text column in df1. And we can basically use all the tricks we just did, right? So now I'm going to go back to df table. I'm calling this C. It's going to be a column called C. And C is basically going to be, oh, I basically have to do all those tricks again. I'll do a few lines to do it. So df text. I believe text is my, yes. So first thing I want to do is I want to basically, I guess I'll create a NumPy array. That's fine. I can convert it into a NumPy array. That's fine. All right. So I'm going to do this in 2 shots, guys. Oh, maybe I could do it in 1. Let's try it. Apply lambda, and I'll call this lambda. I just ran out of ideas. I'll call it lambda x, whatever. So what's going to happen here is, first x is going to be each one of those texts. All right. So first what we need is we need to do what? We need to create our go all the way up here, our text list. So first we're going to do x. We need to split. We need to split the words, right? We need to split the words. We're going to use the str command. Strip the words. This creates a list, as you can see from up here. We're bringing it all together. All right, this creates a list. All right. All right, now to that list, we are going to put it in a NumPy array. Hey, I'm going to have to do this in 2. I'm going to do this in 2 steps. All right, 2 steps, guys, 2 steps. So now I have a NumPy array. All right, now I have a NumPy array. Oh, I could still actually, yeah, I could do this in 1 step, but it might get a little too crazy. So I'm going to make a temporary table called, I don't know, T for temp. I'll call this T for temp. I'll run this. Oh, it's not liking that. It's not liking that. Take that back. You have to apply straight to the series. Apply. I'm sorry. You have to apply straight to the series. So let me do str.split. X was the individual text value. Text values don't have that. So, I mean, I think we could have our own split one, but I would have to probably do an MP split or something like that. But whatever, we'll just do it like this. Since I have to use two steps anyway, or possibly 3 steps. So df, okay, I have that list. I should have probably did this in the original table. And now I'll create another one. It's going to be NumPy array. Yeah, it probably doesn't make sense for me to create another NumPy array. So I'll call this T2. And this is going to be dft. And it's going to be my NumPy array. Again, I don't have to use lambda for this. All right, so I have my NumPy array now. No comma, excellent. And now I can finally do my last step. All right, dfc equals dft2 dot lambda lambda x colon. And now, all right, I'm going to call join on x, but only on the first and the last values. Because remember, we want to join the first and last value. So 0 gives me the first value, -1, remember, gives me the last value. Notice I'm doing a double bracket slicing. I go ahead, I run this, and now in df, you'll notice I have a C. That's what? That's basically the first and last word. Thanks home, thanks it, excuse me sir wallet. It's actually easier to see this if I now go back and delete the columns I don't need anymore. and delete the second column I don't need anymore. I do this trick all the time when I need to, when I'm processing data at work for some fund. Get rid of those tables I don't need. Now, thanks home, thanks it, excuse wallet, I'm today, my English. Boom. All right, guys. So that's practice set, what is this? Practice set 6. Thank you for viewing. Thank you for tuning in. And I'll post this doc up for you as well. All right, guys? All right. Have a good day. See you guys at the next session.